Alrighty, guys, as we wait for the last few classmates to join, you can follow the link in Google Classroom for task 1. We're going to do a Nearpod lesson today. We are moving on to the second part of Unit 1, which is about scale drawings. So on Friday, you completed that rubber duck task that kind of introduced you to scale drawings, asked you what they were, asked you kind of some goofy questions. And today we're really going to dive into figuring out what they are. There's going to be a short live lesson like this that we do all together. Once we finish it, I'm going to send you an individual one like the one you did on Friday to let you do some practice problems on your own. But I'm going to do it a self-paced, meaning you're going to push yourself through it so that you'll have time to be in the Google Meet asking me specific questions. So kind of like me just giving you a worksheet in the classroom as I come around to check on you as you're working. I'm going to just give you a Nearpod practice to do. I can see your answers as you're working, and then you'll have the ability to stay in the Google Meet to ask me some questions about it. Olivia, if you go to the first task in Google Classroom, there is a link. You're going to click on that, and it's going to take you to a website. Or if you have the Nearpod app, it's Nearpod on your iPad. If you click on that, you can also type in this code that I'm putting into the chat. But if you don't have that app, then just follow the link that's in Google Classroom. And it's going to take you right to our lesson for the day. Task 1, there is a link. Alrighty, so again, those of you that are in the Google Meet, we need to start practicing now. This is our third week. Being ready to go by 11:15, 11:20 at the latest. So I see 20 of you in Google Meet. There are only 8 of you logged into the Nearpod right now. So that means 8 of your classmates are sitting here waiting. You need to make sure that you're logging in so that we're all ready to go. Olivia, whenever you click on the link, it's just going to ask you to type in your first name just so that when you answer a question, I can see that it's you. So there's not an account. You're just going to have to click the link in Google Classroom, and then it will open it up, type in your first name, and that's all. But if you're using the app, it's going to ask you for the code that I typed in. But it's a little bit easier just to follow the link that I posted. It's a little bit less buttons. We are getting started at 11:20. If you're in the Google Meet, make sure you're following the link in Google Classroom. We've been doing the same thing now for a couple of days. You should be used to the process. We cannot sit around all period waiting for you guys to log in. Yep, Olivia, I see your name. So then you're just going to notice a screen. And when I get started, I'm going to click through and it's going to change and there's going to be some questions and things like that. Perfectly fine. If you are having tech issues, obviously my directions to log in right away are not aimed towards you. Just communicate to me like you just did, Anna. Perfectly understandable. But that is what it is. Okay, I am going to switch the slide here so that we can get started thinking about the first question. So we are talking about scale drawings. They're very similar to what we talked about last week with scaled copies. We did a little short kind of fun intro to it on Friday. But if you look at this first slide here, if you're in your Unit 1 books, this is on page 61, so you can follow along. You don't have to. We're never writing in the book. You just may use it as like a reference. But it says, here are some drawings of a school bus, a quarter, and the subway lines around Boston, Massachusetts. The first 3 drawings are scale drawings of these objects. The next 3 drawings are not. Okay, so I have my top 3 that are scale drawings, and I have my bottom 3 that are not. Take a minute to think about What do you think it means to be a scale drawing? So I gave you this question on Friday when you were talking about the rubber duck, but I'm going to switch the slide in a minute so that we can collaborate. But we know that the picture goes away, so I'm going to give you a little bit of time to look at this picture to formulate your thoughts. And then when I switch the slide, you can add your answer in. So the top three are scaled drawings of the objects. The bottom three are not. So what do you think it means to be a scale drawing? Olivia, perfectly fine that you don't have your book. Like I said, some people just like to use it as a reference to follow along, but it is not necessary. Kenny, I don't know why. Let me try to give you the code. Or the link. So those of you that are looking at that screen, take a minute to just formulate your answer. I'm going to switch it in a second. I just want to get this code copied. What do you think it means to be a scaled copy or a scale drawing? Sorry. Can you try to use that? Just link right into it. Okay, I am going to switch the screen so that you guys can share your answers. Again, if you want to keep looking at this picture, it's on page 61 in your book. But all you're going to add in here is, what do you think a scale drawing is? And then as you're typing in your answers, I'm going to reiterate, if you're having tech trouble getting in, that is perfectly fine, but you have to communicate that with me. Okay, you can see two of your classmates doing that. That's the right steps to take. If you're not having tech issues and you're not getting into the AirPod, the Nearpod, then that's going to be addressed individually. Perfect. An exact picture of the original object. Okay, so Olivia, you're just answering the question. Whatever you think, what do you think it means to be a scale drawing? So a drawing that looks the same as the first one or is bigger or smaller, good idea. Drawings with the same angles as the original shape. I love that idea. That's almost exactly like what we were talking about last week with scaled copies. Someone's bringing up the idea of multiplying a scale factor, so maybe that's involved too. Awesome ideas. Okay, so you guys have some really good ideas here. We're really honing in on the fact that it's pretty much the same thing we talked about last week. Last week we talked about scaled copies, but they were more just geometric shapes. So I have a triangle and it's getting bigger, or I have a rectangle here and my scale copy is getting smaller. So we really talked about those scale factors, and now we're talking about scale drawings. So the idea here is that it is the same picture, like some of you are saying, bigger or smaller. It's not an exact replica, but it does have those same angles, the same shape. It's getting bigger, it's getting smaller, all that same thing. An exact picture of the original. Yes, it's just a little bit bigger or a little bit smaller. So it's pretty much the same idea as what we were talking about last week with scaled copies and scale factors. But when we're talking about a drawing, now we're just talking about things in real life. So if I have a map of a city, it is a smaller version of what the actual city looks like. Or if I have, we're going to look at a basketball court on the next page. The actual dimensions of the basketball court scaled down so that we can see it and hold it and do a little bit more work with that. Good ideas, guys. So I'm going to switch your slide. So now you're going to see a basketball and a court. It says below is a scale drawing of a basketball court. The drawing does not have any measurements, but it does say that 1 centimeter represents 2 meters. So this is your example of a scale drawing. We know what an actual basketball court looks like. However, we can't draw one that big on our desks in order to figure out some measurements. So we scale it down to its exact shape, same angles and everything, but then we have to change the sizes. Okay, the statement 1 centimeter represents 2 meters is the scale of the drawing. Okay, so now I'm going to push you to think, what do you think that tells us? Okay, so we're looking at this scale drawing. We have that 1 centimeter represents 2 meters. Take a minute to think about, what do you think that tells us about the picture? I'm going to leave this up for a minute so you can formulate your thoughts before I change it. So we have a scale on the picture that says 1 centimeter represents 2 meters. It can also be expressed as 1 centimeters to 2 meters, or 1 centimeter for every 2 meters. What does that tell us about the picture? Take a minute to think about your answer to that, and then I'm going to switch the slide to let us type it in. Those of you that just joined because you're having trouble, again, as always, don't stress about missing. I'm always recording the lesson, so you're going to have that. So all good. So what do you think it means? So I'll switch the slide here. What does that scale tell us? So if we have that scale drawing of a basketball court, if 1 centimeter is equal to 2 meters, what does that mean? What kind of information does that give us? Exactly. So it's telling us that the scale drawing and the actual basketball court, not the same size. I love that idea. Every 2 meters, there's also 1 centimeter. We're going to dissect that a little bit once we get some more answers in here. So how can that information help us when we're talking about the actual size of the basketball court? Exactly, yes. So that scale is telling us that that picture on my paper is not the same size. It's not the same as the original. Okay, so I like all of these answers. So I'm going to keep us on the screen, but I'm going to push you to think about another question. So I agree that it tells us that it's not the same size, but be a little bit more descriptive there. What does it tell us specifically about the size of the basketball court? So if my scale drawing says that 1 centimeter is equal to 2 meters, how can that help us figure out the size of the basketball court? Because your guys are all onto something by saying they're not the same size. But specifically, how can that scale help us figure out the size of the basketball court? So again, I'm phrasing a different question. How does that scale help us figure out the size of the basketball court? Type in a new answer. Because I do agree, we're all saying that the scale drawing and the actual court is not the same size, but then how does that help us? Yes, I like that idea. Coming back to what we were talking about with scaled copies, we can multiply the numbers to get the size of the court. So on the next slide, we're going to look at specifically what can we multiply. And again, I'm going to come back up to this second answer that got posted. For every 2 meters, there's 1 centimeter. Okay, so what this scale is telling us, to take another minute to finish up if you're adding anything to this page, what this scale tells us is that if I measure 1 centimeter on my scale drawing, that represents 2 meters in the actual court. So if on my scale drawing, there's something that's 1 centimeter long, that means in real life, it's 2 meters. Or if I have something on the drawing that is 2 centimeters, it's going to be 4 meters in real life. So think about your scale factor. What would your scale factor be taking 1 centimeter to 2 meters? That's the idea of multiplying. Okay, we have to make sure that we are being appropriate in the Nearpod. Okay, we cannot be adding comments like this. We're only contributing to things that have meaning to the questions. Okay, keep in mind that these responses are anonymous to you guys, but they're not anonymous to me. So I have all of your names here. Okay, I'm going to switch the screen. So now we have the court again. You have the scale and you have a table. So you have all of the dimensions written to you. So in the drawing, the length of the court's 14 centimeters, the width of it is 7.5, hoop to hoop is 12.4, and from the 3-point line to the sideline, we're 0.5 centimeter. So take a minute. I'm going to switch the slide so you can do some drawing and some math work. It's going to look exactly like this, but I want you to try to figure out, thinking about this, thinking about what we just talked about on the other slide, how can you figure out the actual lengths in the court? So you can see that same picture here. So take some time to fill in those actual lengths. if my scale says that 1 centimeter represents 2 meters, and again, that means that 1 centimeter on the drawing is 2 meters in real life. So if length of the court is 14 centimeters, what's the actual length of the basketball court? Let's take a minute to fill that table in. We're going to share some answers out. Okay, so Olivia, this is your draw page, so you can just try to do the problem. It doesn't have to be right. I am going to show us the right answer, but I'm just going to give you guys a little bit of time first to try and see if you can think about what that means. If 1 centimeter on the drawing is 2 meters in real life, then 14 centimeters in the drawing is how much in real life? I love the work that you guys are showing. If you submitted your answers, just hang tight for a little bit. Some of your classmates are in the process of writing, so I'm going to give them a few more seconds to finish up what they are writing. You guys are all on the right track, though. Perfect answers. Okay, take another minute just to finish up what you are writing. You are all on the right track, so be confident in your answers. And then I'll share my screen just to show, and then we're going to move on. I'll give you a couple more seconds to just finish up what you're writing. All right, if you're still writing, that is fine. I can see you're all on the right track, so I'm just going to briefly discuss this just to make sure we're all A-okay. So you all found that you could just take everything in the scale and multiply it by 2. That's the same work we did last week whenever we were talking about scale factors. So whenever you're given a scale in a scale drawing, it's the same thing as just picking out those corresponding sides like we did last week with scale copies. So my scale tells me that 1 centimeter was equal to 2 meters. So I drew my arrow in to find my scale factor. Keep in mind, I know that us doing that math of 2 divided by 1 is very easy in our heads and we don't have to show that work. You just want to be careful that you know the process on how to do that if you're given numbers that aren't easy to multiply in your head. But I can see that my scale factor that takes me from centimeters to meters is 2. So that means for every centimeter length in my drawing, I'm going to multiply it by 2 to get the length of the actual court, which a lot of you did. Some of you just be careful with part D. When you multiply half by 2, you're going to get 1 meter, so just be careful there. But you guys all did really, really good with that. But again, keep in mind the process behind finding the scale factor. This one was easy because I had 1 centimeter, but pay attention in case those numbers aren't easy to do in your head. Draw your arrow in from the drawing to the actual image so that you know the order in which you're dividing. So you're finding your scale factor and you're scaling it up. Perfect. Okay, what you're going to do now, if you're in Google Classroom, there's a second Nearpod, so task 2, but it's a self-paced one. So that means I'm not leading it like this. There are 4 problems very similar to this basketball problem. So I want you to open up that Nearpod, work on that. I'm going to be watching on this screen as you're working so that I can help you as you go. You are free to stay in the Google Meet so that if you have questions, I can work with you. But it's think about it as me giving you a practice worksheet to do in class and then asking questions if you need help. So open up that link, work on that. Like I said, I'm going to be watching you as you are working. You do not have to stay in the Google Meet. However, if you have questions, please take advantage of the fact that you can be in here working with me. If you are not working on this during sixth period and it doesn't get done, if you get some questions wrong, I'm going to go through and kind of make a list, and then I'm going to send you some feedback to come and work with me during 10th period on this. Okay. So your goal right now is to do that second task, your individual Nearpod problems like this. You do not have to stay in the Google Meet, but if you have questions, I strongly recommend staying in so that I can help you. When you're done with that, you're going to do the third task, which is an Edpuzzle. So there's no practice problems from the book, none of that. You're going to do the second task. It's a link. You're going to work on that. When that is done, you're going to do your Edpuzzle. You do not have to stay in the Google Meet to work on the second task. I advise that you do, like I said, so that I can help you and answer your questions. However, if you feel confident and good, you are free to kind of work on that on your own. If you're not in the Google room with us right now and I check your work and I notice a lot of mistakes, then I said I'm going to reach out to you just so that we can talk during 10th period to figure that out. But as far as we're concerned right now, follow that second link, work on that, then do the Edpuzzle. So you have the rest of sixth period and the rest of 10th period to do all of that. The code for the second Nearpod is, I'm going to type it in the chat, EBMWO. Okay. So as you guys are working individually, like I said, I'm looking at your screen, so I'm watching you as you work. So you are free to work off on your own. I'll be aware of who's working and who's not working in that manner. But like I said, if you want to just hang out in the Google room in case you have questions, perfectly fine. If you feel like you're confused, hang out in here. I'll help you as you go through. But that's our goal. Finish these and then go ahead and do that Edpuzzle. You do not now need to stay in the Google meeting room, but it is open for you as you are working so that you have questions. It is a lot easier for me to answer questions moving individually like this than as a whole group. And again, by the end of sixth period, if this is not started, or if you're working on it and you just have some stuff that's wrong, perfectly fine. I'm not grading it. But I am going to reach out to you individually just to help you during our 10th period block. Olivia, did you follow the link